Hello again. As you know, I am Eli, the computer guy, and I am creating authorityless, gatekeeperless, free to the end user technology education that hopefully empowers you to do whatever the hell it is that you want to do. Now, do remember, free to the end user education is not free. Things cost money, so if you're able and willing to support this particular project, I'd highly appreciate you throwing a couple of dollars in down on the donor box or whatever crowdfunding link we have below. That's what kind of helps all of this keep going. So anyways, we're going to keep continuing on our cyber security curriculum, and we're going to be talking about honeypots today. So I've done a lot of classes in the past talking about overall concepts, employee security policies, layered security strategies, that type of thing. Today we're actually going to be talking about one of the specific types of technologies that you can use for cybersecurity within your infrastructure. This is something that's been around for a long time, and it is an absolutely wonderful type of tool. So the question is what is a honeypot? Essentially, think of a honeypot it's a trap for hackers or anybody that might intrude into your system. It is something that looks valuable. It is something that looks vulnerable. So the little hackers sneak up on it, and then once they snuck up on it, they basically reveal themselves. So essentially, you know that they are there. One of the biggest problems when you're dealing with cybersecurity is simply the fact is that many times you do not know you are vulnerable, you do not know that you have been compromised until something happens that is so visible you realize there is an issue, right? So when a hospital, when they have their database gets encrypted for a ransomware attack, right? When your database gets encrypted, that's pretty darn obvious. Oh crap, we've been hacked! What may not, what the cybersecurity people or the IT administrators may not have realized is actually you got compromised a year ago, right? Somebody brought their little BYOD device in, bring your own device. They brought their own computer into your internal infrastructure. When they did, that was infected with something. They connected to the internal infrastructure. That computer then infected something else and basically allowed the hackers in the outside world to install something called a RAT, a remote access tool, and they have had that remote access tool sitting on some machine internal to your network for the past year, and they've just been kind of, they've been just trying to figure out what to do with it. I mean, you have to understand, hackers are just like everybody else, right? When they see an opportunity, they don't necessarily know what their plan is. They don't necessarily know what they want to do. It's like, oh, did you know we installed a rat into a hospital today? Really? I didn't think we were going to be able to do that. I wonder what we should do with that rat. And so they may sit there and they may, well, let's do a scan of the infrastructure, see what might be vulnerable. Ooh, there's an Active Directory server. Ooh, there's an email server. Oh, there's a database server. I don't know. Do you think we should go after the Exchange server, the database server? Well, everybody's focused on the Exchange servers nowadays because there's that big Exchange server hack. Maybe we should look at a different vulnerability, something that's going to be a little bit more covert. And basically, they may be on your infrastructure for days, weeks, months, literally years. They may be on your infrastructure for years. And if you do not have any systems in place that are going to detect their intrusion, they are just going to sit there until they find the vulnerability that they're looking for. Again, one of the big problems is once something like a remote access tool is inside an environment, is that the hackers can wait for you to screw up. Like, imagine you're creating administrator accounts and you hand that over to an intern or you hand that over to a junior level admin and you say, hey, I need you to create a few of these administrator account so we can do a couple of things. What happens when that junior level admin just decides to make the passwords for those new domain administrator accounts 1, 2, 3, 4, 5, 6, right? Nobody's supposed to know those exist. Nobody, they're the only ones that are going to be using it, so they want to put in an easy to remember password. And so just one junior level admin doing something stupid, and even if the senior admin comes back and after a day or 2 or 3 finds out there's a problem and then fixes it, well, basically during that window of opportunity, they're there was a system within the network that was compromised and might be able to go after the specific attack. Again, think about like the Exchange server. So I'm filming this in 2021, and so recently there was an Exchange server attack. Going after Exchange servers and compromising them. And so one of the things that a hacker can do is once they have a remote access tool installed within your infrastructure, once they scan your network so they know everything on your network, they do a proper audit of your network, right? They know what's on your network, they know the devices and the hardware and all that kind of stuff. One of the things they can do is they can just sit back and they can wait for somebody to document a vulnerability. Oh, look, they just documented this Exchange server vulnerability. I think I can go after this person because they have an Exchange server. And so that's why you need tools within your infrastructure to actually detect anybody that may have intruded onto your infrastructure and try to deal with the problem before it gets bad, right? I would rather deal with a hacker while they're still doing Nmap scans. Versus when the database gets encrypted, that type of thing. And so basically all a honeypot is it's a trap for the hackers to show that they are there so that you know that there's a problem and then try to track them down. Basically it's a decoy system or device used to get a hacker to expose themselves. So that's all this is doing, is getting the hacker or the hacked device to expose themselves. There are many products available. Again, one of the things in the technology world, some of the new people get confused about when I talk about honeypot, is there's a difference between a technology and a product. So a honeypot is basically a technology, it's a concept. There are 1,000 different types of honeypots out there. You can build your own honeypots. Basically, this is one of those things where I explain it to you, and then afterwards you go Google search and you figure out what honeypot you want to use. And then finally, this should be part of what's called an intrusion detection system. So what an intrusion detection system is this is a system that is looking to see basically if there are intruders within the internal network. And again, the goal here is that you're trying to find them while they're still doing the ping sweeps long before they can start to do anything else. That's relatively stupid. When you start thinking about using a honeypot, again, with all these types of technology, it's a strategy. Remember, in the technology world, in the cybersecurity world, this is as much an art as it is a science. The products that we use are engineering, they are science. How we deploy those products into the field, that's a form of art. So one of the things you have to think about is, what are your resources? How much money do you have? What's the institutional knowledge? All of those types of things. One of the big questions to ask yourself is, do you have current problems, concerns, right? When you look at the log files for your Active Directory server, or maybe a Linux server with SSH, do the log files for SSH show a lot of failed login attempts? Does it appear that somebody is trying to brute force attack into SSH into your Linux server, right? Are you having issues? Are you having weird slowdowns, right? Especially in 2021, going forward, networking equipment nowadays should be awesome. I remember when even when you had the best networking equipment, everything was still dog slow. Nowadays, right? You have gigabit, networking equipment. You may have 10 gig networking equipment. All your systems should be running fine, right? The network should not be the bottleneck. So are you having weird bottleneck problems on the network? Are you having weird things that seem almost like denial of service attacks? Again, one of the big issues that we can have is legacy systems within an infrastructure. Maybe an old telephone system, maybe some kind of old CRM solution, some logging solution. Anyways, you'll have something that's like 15 years old. And one of the issues you may have with those old systems is the licenses for them used to only allow a very limited number of connections, right? So we used to have this telephone logging system that connected to the PBX. And you could only have like 2 people logging into the system at any one time. If 2 people were logged into the system and anybody else tried to log in, it would fail out. So one of the things to look at is are you having weird login issues especially with some of these old legacy systems that seem like a denial of service type attack. Like when you look at it, you're like, well, that seems like a denial of service attack. I don't understand what's going on. One of the problems there is you may have something on your network that's trying to connect to that box, and when it's trying to connect to the box, that's using up those resources that are available and give you no problems. And one of the big things to be asking yourself is what problems do you actually think that you have now? Now, one of the big things, this has come up before when I've talked about cybersecurity, is to remember surveillance is not security. This is one of the biggest pains in the butt. Again, I used to sell digital surveillance cameras, and people thought surveillance cameras would like prevent people from breaking into their buildings or whatever. And I had to explain to them, no, you will have a high quality video of them breaking into the building. But again, it's not a fence, right? A honeypot is not a firewall. A honeypot is not a group policy. A honeypot is those types of technology are real security technology. A honeypot is basically a form of surveillance. You are seeing what is going on in the network. And so the big question that you have to ask yourself is, if you're going to deploy a honeypot, is what happens when you detect an issue? Again, in the world of technology, one of the biggest problems that we have is people feel that if they buy a product or deploy a product, that basically their problem is solved. Don't worry, CEO, we have a honeypot. Okay, great, great. What happens? Literally, what is the policy? And again, you'll notice when I keep talking about policies and documentations and regulations, you realize how much of this job is a hell of a lot of paperwork. What is the policy? What is the course of action when you see your honeypot and basically there's an SSH brute force attack against this? So you basically create this dummy system. It has SSH open. All you're waiting for is people to try to connect to that. Okay, now you see a brute force attack. 192.168.1.25 is trying to brute force SSH into your honeypot. Now what? No, seriously, now what? Now what do? Do you get a notification? So you could have some kind of system where you actually get like an SMS notification. There's a brute force attack currently going on with your honeypot. It gives you the IP address. One of the things to ask yourself, again, when we talk about things like documentation, when we talk about things about cleaning up the rat's nest in your server room, when you know that 192.168.1.25 is attacking your honeypot, how long will it take you to track down 192.168.1.25? Do you know how to pull up in your switch what port that IP address is currently connected to on the switch? And then is everything documented on your patch panel so that when you go to your patch panel, you can say, okay, so port 30 in the switch corresponds with, port 100 on the patch panel. Port 100 on the patch panel, that goes to the conference room. Can you do that? These are the things that you have to be thinking about when you're thinking about trying to deploy the cybersecurity in the real world. Again, so many people focus on the technology. Oh, honeypot! They don't think about, okay, well, what happens next? Again, what happens next? Who knows? You could have an automated system. One of the interesting things we'll talk about in a little bit is the whole idea is once you know how to parse text, so parsing text is basically reading text with some kind of scripting language, PHP, Python, whatever else. One of the interesting things that you can think about is depending on how much control you have over your network infrastructure, so let's say you're using open source routers or something like that, you could actually have something basically trigger an event where if one device tries to brute force into your honeypot, that goes into a log. That log is automatically read by something like a Python script. That Python script then literally writes the IP address that's trying to do the brute force into a blacklist somewhere, and then all of your networking equipment can update rather quickly, periodically, every 30 seconds, every minute or whatever, with anything in the blacklist. And basically, if that IP is now in the blacklist, then your networking equipment can literally shut down all communication going to and from that particular IP, and then you can auto-isolate the device that is causing a problem. But all of that has to get built. It's like there's the honeypot, and then there's everything you build once you install it. One of the things I'd argue when you're thinking about doing a honeypot strategy is how to create very visible services, basically very visible honeypots, and then I would also create hidden honeypots. What do I mean by this? So if somebody goes into Network Neighborhood or My Network Places or whatever the hell Microsoft calls it nowadays, right, and they look at your local area network, right, when they pull up the local area network, they're going to see the host, they're most likely going to see shared printers, and they're going to see servers, right, Exchange server, Active Directory server, whatever else. If you're like a lot of administrators, basically they make the naming of the servers pretty easy. Email server, right? So one of the things to be thinking about is when a hacker comes into your infrastructure, or an employee decides to do something stupid, the thing that they're most likely going to try to go after is anything that is obvious. If you have a server named the email server, if you have a server named the file server, if you have a server named the VPN server, like literally name the damn thing the VPN server, right? Then that's an attractant. So people, like a lot of times manually people go, ooh, I wonder if I can screw around with that particular server. So that goes for the very obvious things. One of the things that I'll say is if you do honeypots with very obvious servers, again, we go back to employee security policies, we go back to employee policies. One of the biggest problems that you are going to see is that your employees are doing stupid things on your network. Again, a big issue we have in the modern world is there are a lot of people out there, they run off to get their degrees in IT or networking or go to some boot camp on the side or whatever else, and as with everybody, it's completely normal. They go into work. They're wondering, you know what? I wonder what our infrastructure looks like. I wonder what I can do, right? They went home over the weekend. They saw Network Chuck's, video on how to hack, VLANs or something like that. And then they come into work on Monday, and then they're kind of curious about whether or not they can hack their local VLAN. This causes all kinds of problems. Again, remember, something that I try to remind you folks is when you're actually doing penetration, when you're actually being ethical about cybersecurity, actually being ethical, not this fake ethical crap, this crap people make up to make themselves feel better, but when you're actually being ethical, one of the things is when you're actually being ethical, you need to think about the damage that you might do to the infrastructure. You need to be good enough when you're doing things like penetration testing that if you are successful with your attack, you know when to pull the punch, you know when to stop, and you know enough that if you cause a problem, you know who to talk to and basically tell them what the problem is. Again, with the SQL injection attack, if you have a whole list of prices, basically if you have a column of prices and somebody is able to inject Bob into a column of prices, that's going to be a disaster as far as the database is concerned. And so if you are actually able to do that, right, if a penetration tester does that, they need to be able to get the database people on the apartment, ASAP to say, crap, I was able to do this. You need to get it out of there, right? But one of the big problems you have is, right, a lot of these new, wannabe tech people, they come in, they download low orbit ion cannon for some reason onto their system, and they just start targeting crap. Oh, employees. Anyways, so one of the big things that you're going to be thinking about, especially when you have these very visible honeypots that you're going to be putting up there that you're going to do attract people, is what happens when you find out that employees are attacking these honeypots. And again, this is something where you need to think about beforehand. You need to know what the disciplinary policy is going to be, and you need to know what you're actually going to do in that event. What happens when you find that Susie has just deployed the low orbit ion cannon into what she thought was the email server? That's a real serious problem, right? So that's one of the big things. So it's the visible servers, the visible honeypots, those go after generally the manual type of stuff. Then what I would say is you should have hidden servers. Not really hidden servers, just kind of like obscure servers, obscure boxes, right? If you have a network of 100 computers, right? So you have some, VPN, email server, FTP server, whatever, right? Make it vary. But then just have, host 23, right? So if you have a whole bunch of different computers on your network, just, there's whatever naming convention. So I would just slot in a honeypot into that naming convention and basically just get it lost in the shuffle of all of the other devices that are on the network. Why that's important is because there is nothing about its naming convention that should attract somebody to do something just randomly like that. They shouldn't be doing, port scanning or whatever on some random ass computer. And why this is good then is basically when you have an automated attack is going to try to scan your entire network and look for all vulnerabilities. And so it's just going to go down the list. It's going to scan all the servers it sees, and then it's going to go down the list. Computer 1, computer 2, computer 3, computer 4, computer 5, computer 6, so on and so forth. And so when you see a random ping to this basically obscure box that nobody should know that it exists, that tells you something's going on with the network. Again, if you have an obvious box, your employees may be doing something stupid. That's not necessarily an intrusion. That's an employee issue, right? But when you just have this obscure box, why is somebody doing port scanning on just a random ass computer that's in the rest of the mix of all of your different host machines. The only reason most likely somebody would be doing port scanning is if it's for nefarious activities and they're trying to figure out the next way to do an attack. And so if you put this honeypot there, you log, because you log the IP address, you log everything else going on with that that basically remote access tool or whatever that's trying to infiltrate that system. You log all of that, you see what the IP address is, and then you can backtrack and then try to take that device, whatever has been compromised on your network, offline. And so that's why you want to do a hidden one, because like hidden or obscure one, because your users shouldn't just be randomly pinging it, even if they are networking people. They shouldn't be doing port scans. It's just like one of those just random 1 out of 100. The only reason that you would ping that thing is either that it exists and you're just doing some troubleshooting, or that you don't know that it's a honeypot sitting out there waiting to detect some type of attack against the systems. And then the other thing that I would say is look for vulnerabilities that you don't have. Again, when we talk about compromises, remember with remote access tools or whatever other type of tool that a hacker is going to be using, at any one time, they may be trying to go after specific services. There may be a vulnerability in SSH. There was just that vulnerability in Exchange, right? So hackers may have compromised countless networks, right? So let's say one hacker can compromise 500 networks. Out of those 500 networks, at any one time, the attacks that they have in their tool bag will only work against, let's say, 10% of those networks, right? So maybe right now they're attacking for SSH. In the future, they're attacking for Exchange. Past that, they're attacking VPN servers, so on and so forth. But they can only attack the vulnerabilities that actually exist in your network. But simply because they're not able to attack doesn't mean that they're not already in your network with one of those remote access tools. So basically, if you look for vulnerabilities that you don't have, let's say that you're running completely Microsoft servers and you're not using something like SSH. For whatever reason. You're not using one of these other services that Linux may be using. You set up a honeypot to detect attacks against Linux servers even though you don't have Linux servers, and then what you might find out is that the device or whatever that's already in your infrastructure is currently trying to attack Linux servers. You just don't have that actual vulnerability, so then you can go and you can try to remediate that problem. You can try to get rid of that device before the hacker decides to flip over and actually start going after Exchange servers or something that you actually do have. So when you set all of this up, be thinking about that. Again, you need to be thinking about what the core problem is. Is the core problem really the brute force attack? Is the core problem really the ransomware? Right, that's a problem. It's a big problem, right? That's the obvious problem. But the core problem that you're trying to deal with is that somebody is sitting on your internal infrastructure and is able to attack your internal infrastructure. So you need to create that strategy to find those types of things, even if you're currently not vulnerable to whatever the specific attack is. I would argue, when you're dealing with a honeypot, track any access attempts. One of the interesting things is pings. Pings can even be tracked. So when I ping 192.168.1.10, it gives me a response. You can actually log that and put that into a log file to be parsed by some coding language or whatever else. So again, if you have that obscure honeypot that nobody should even know that it exists, and all of a sudden it gets pinged for some reason, it's like, oh, hey, look, 192.168.1.50 just pinged my honeypot. Let me go see what's going on with 192.168.1.50. Again, with any of this kind of stuff, you have SSH, you have remote desktop, you have FTP, you have all kinds of services on the network. So you have to be thinking about what services you're actually going to be trying to track for, and then track for any kind of attempts on those services. Now, log files. One of the big things, right? So I've been doing a lot of what I call tech office hours lately. So I actually get on Zoom and I talk with people all around the world who all ask me how to get a job. Why, Lord, why? I want to talk about technology projects. And they're like, job. Anyways, one of the big things I tell everybody that wants to get a job at this point in time is don't worry about the A+, don't worry about the Net+. CCNA, that's its own argument. The rest of it, one of the things I tell people is learn to code. Learn to code. Most likely Python. I don't know, there's a lot of different languages, what you decide to code for. But the big thing is learn to code, 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 learn to code. And that in the modern world, if you're going to be a systems administrator, you need to learn to code. Now, to be clear, back in 2000, basically when I got into formal IT, so I was in the Army in electronics and then went into formal IT in 2000. Back then, you didn't need to know how to code. Literally, if you understood Microsoft, if you had your MCSE, you were set. And then you had to know some networking. And then past that, then you had to learn some Linux. And then past that, then you had to learn back. Well, we're 20 years down the pike. At this point, learning to code, like telling people to learn to code, is just, if you're going to be a system administrator, you need to learn how to code. And the reason is, in these modern systems, is because that you can create code to basically automatically trigger things to occur when events happen. So again, think about this from a security standpoint. If I have a honeypot and somebody pings the honeypot, and nobody should be pinging the honeypot, if I can put that into a log file, that log file can be read by Python. Python can then trigger a whole bunch of different events to happen on your network. Python can trigger an SMS message using Twilio so that you get an SMS message telling you that there's a problem. It can use, whatever to ping like an Arduino or a Raspberry Pi to literally sound an audible alarm. Intruder alert, intruder alert, intruder alert. It can write to some other kind of like a blacklist file, and you can have a Python script sitting on your networking equipment, let's say your open source networking equipment, that can constantly read that blacklist file, and if an IP address is in the blacklist file, it can automatically shut down all communications going to that particular IP address, so that it can no longer attack the internal infrastructure, it can no longer send communications out to a command and control server, nor can it get communications from that command and control server. But in order to do all of that really fancy, cool stuff that is worth a lot of money, you gotta learn how to code. Basically, remember, log files are your documentation of what has happened on your network. So again, with all of this, with coding and everything else, you need log files. Make sure that you turn log files on with whatever you're using. Your networking equipment probably has log files. Your servers have log files. Your honeypot, you should have those as log files, the whole 9 yards. You can parse the log files from multiple servers and devices and give you a better view of an intrusion event. Again, one of the big things to be thinking about whenever there's an intrusion is that it's an overall event. Multiple things have happened, right? In order, you have to be thinking about not just the attack that's currently going on, the brute force attack going on against SSH, but then you have to be asking, okay, well, how did this system get compromised to begin with? And you have to be able to backtrack with all that, right? If you have log files, you can go through and then you can match events to see what happened, to see what was the precipitating action that caused your systems to initially have this intrusion in the get-go. Again, that's one of the nice things if you know how to use something like Python, especially if you know how to use something like Python, some kind of database engine like MySQL, is you can take these log files, you can parse the log files into all their bits, you can dump that into a database, and then you can try to correlate information and try to see exactly what was occurring, so that you really have an understanding of what the entire event looked like. Then again, as I've said, you can trigger events based on the log files. You can do notifications, you can do dynamic firewall rules, and the whole 9 yards. And so again, this is one of those things you need to be thinking to the next level. So many people are like, oh, I know honeypot, right? I figured out what a honeypot was. I configured a honeypot. I put the honeypot on the network, and so yay, I'm a cybersecurity person. But it's like, yeah, okay, so but what happens now? How are you making the systems more automated? How are you making the systems more secure when something actually does occur? Now, one of the things that I will warn you, especially for all the noobs out there, is harden your honeypot. Harden your honeypot. Don't have no soft honeypot. Have a hard honeypot. A hacker taking control of your honeypot would be sad. So when we talk about these honeypots, right, basically this is just software that gets installed most likely onto a Linux machine. It's either a Linux distribution itself, or it's software, whatever, that gets installed into a Linux machine, or it's your own configuration of a Linux machine or anything else like that. But remember, this is an actual machine. This is an actual device that's sitting on your network with an IP address and network communication and all that kind of stuff. Honeypots can get compromised too. Like if you're so focused on your Exchange server getting compromised, and then you miss the fact that your honeypot is the thing that actually got hacked and got compromised, that could be a really bad problem. So when you think about password policies for your honeypot, when you think about firewalls for your honeypot, when you think about all of the different things, do make sure that you actually harden your honeypot. It would be sad. It'd be sad. Look, I put a little sad face there. It would be a sad face. If your honeypot gets compromised, it is sad. Sad. Again, verify the security on your honeypot is adequate. Again, that's one of those things. A lot of times people feel like, oh, I am putting this security device onto the network, therefore, because I call it a security device, it's de facto secure. No, it has password problems and all that, like anything else does. And one of the things that I would argue is wipe and reload your honeypots periodically. This can be very easy if you're using virtual machines as honeypots, because you could use a virtual machine. It doesn't have to be a physical machine. But basically, again, if your honeypot gets compromised for any number of reasons, wouldn't it suck if the hacker installed a remote access tool onto your honeypot a year ago? And now your honeypot is attacking your infrastructure. So if you wipe and reload, basically like with a lot of this stuff, it just cleans out any possible problems that may be there, starts you off with a blank slate. It's better for security. When you start to go and take a look for honeypots, again, if you want to go out there and get the distro or get software in order to do the honeypot thing, there's a crap ton of them. Again, this is basically just an idea. This is just a concept. There's a whole bunch of different solutions out there. I don't know, you have ICS honeypot, fake ID honeypot, small daemon that creates virtual host, honeyD, low interaction honeypot, high interaction honeypot, honeypot project or honeynet project, generic authenticated data feed protocol, medium interaction SSH honeypot, lightweight fake SSH server, right? Even a WordPress honeypot. So again, that's one of the things to be thinking about too. If you have WordPress sites or if you have some kind of specific technology that you're using, specific products that you're using on your infrastructure, there may be specific honeypots that are designed to emulate that type of device very, very specifically, and so that's something that you might want to deploy. I just did a basic Google search, pulled up this particular page, did a screenshot, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16 different types of honeypots that are just there. One of them is very interesting. They have the it spins up access points, which is actually pretty cool. Oh, where was it? Oh yeah, Black Albany fake AP generates thousands of counterfeit 802.11b access points. So that's kind of an interesting thing too. Again, when you're thinking about honeypots, it's not necessarily a Linux server, an Active Directory server. Think about, again, putting up access points or whatever else. Is somebody trying to connect to these fake access points within your infrastructure, and is that a problem? So anyways, that was a short class. Woohoo! See, I can do short classes. Every once in a while, I can actually do a class that's not 3 hours long. Only once in a while, though. Only once in a while. So that's basically the idea of what a honeypot is. That's the idea of why a honeypot matters. And again, when you go out there and start playing with this, you need to be thinking about this in that overall. When we talk about that layered security, this is a component of intrusion detection. This is not the only thing you should have for intrusion detection. This is one component you should have for intrusion detection to try to show you that there is an actual problem. Because I can tell you, a lot of the networks out there, they have already been compromised. Just because the attack has not been obvious doesn't mean your systems haven't been compromised. I think about this with the NSA attack. Again, right? I think it was Yahoo. Again, real world. Yahoo, the NSA essentially tapped into their fiber lines. Yahoo had 2 data centers, and so they had replication and communication between those 2 data centers. They had a dedicated fiber optic line, and the NSA somehow went in and basically spliced the fiber optic line, put their own little man in the middle on that fiber optic line, and then read every bit of data that was going through that fiber optic line, right? And that's something to be thinking about. Again, we talk about things like intrusion detection is it may not be an attack like ransomware. Again, one of the big problems we have nowadays is when you hyper-focus on one attack, one vulnerability, you may not be focusing on others. Everybody's so focused on things such as ransomware, they may not be thinking about some other type of attack or compromise of your systems, and so that's something to be very careful with there. And yeah, so there you go. That is the Honeypot class for the day. Again, if you like what I do, you like the education that I'm trying to provide, authorityless, gatekeeperless, free to the end user, think about throwing a couple of dollars down below if you want to. As always, I enjoyed teaching this class and look forward to seeing you at the next one.